Yeah, guys. Today, as part of the session, we are going to study about a concrete class. What exactly this concrete class is, followed by differences between abstract class and interface, and what additionally we can study differences between abstract class and an interface, and introduction to exception handling mechanism. Introduction to exception handling mechanism. So these are all the concepts which I want to explain as part of the today's session. And after that, guys, maybe from tomorrow, we do have a couple more concepts in core Java, but we will see later. But once we are done with these Java concepts, then we will jump on to the WebDriver. Maybe tomorrow we will directly start with the WebDriver concepts itself. Okay, that's fine. So the first and most thing which we need to know is about a concrete class. So let me open this Java documentation. Okay, so here, concrete class. So what exactly a concrete class is? In a simple words, I can say that a class which has implementations for all the methods. It don't have any unimplemented methods inside that. Okay, a class that should have everything implemented, which don't have any unimplemented methods. So maybe implementation might be of a two types. It may extend a parent class, or okay, it may extend a parent class, or it may also implement interface methods also. That's fine. Either the things, that's fine. But the bottom line out over here is it has implementation for all the methods. Okay, which we can also call it as a complete class. Right, and this class we can call it also as a complete class. Complete class. Even we can create an object to this class, right? So the class which has a complete info, a complete methods and all those things, we can call it as a concrete class, and even we can create an object to that particular concrete class. Okay, so that's the thing about a concrete. In other words, we can say that a class which is not an abstract class, we can call it as a concrete class. Okay, which is not an abstract class. Abstract class contains unimplemented methods, and a concrete class doesn't contains any kind of okay, any kind of unimplemented methods. Okay, cool. In such situations, we can treat this particular one as an okay. In such situations, we can treat it as an concrete class itself. And here there are certain differences between an abstract class and as well as a concrete class. Like abstract class will be defined with an access modifier, abstract as a modifier. And moreover, in concrete, as everything should be implemented, you no need to define abstract for this particular concrete class. And an abstract class cannot be directly instantiated using a new keyword, but whereas a concrete class can be instantiated with a new keyword. An abstract class contains one or more abstract methods. A concrete class cannot contain any abstract methods. Okay, an abstract cannot be declared as a final, whereas a concrete can be declared as a final. Anyways, we will see what exactly this final ahead. But the ultimate point out over here is a class with a full length of an implementation. We can treat that particular class as a concrete class. Okay, a full length of implementation, we can treat it as a concrete class. That's it. Done the deal. And then the next point out over here is what exactly the differences between an interface and as well as an abstract class. So we studied about an interface in the last session, right? A set of rules basically we are going to define, and within an interface we have a bunch of abstract methods are defined in that particular interface. And there are some rules that you need to create as part of this interface. Interface cannot hold as a constructor. Interface cannot hold an instance variables. Interface cannot hold static methods, and you cannot create an object to the interface directly. And you no need to define a variables inside the interface as a static. Okay, any class that implements an interface and the class cannot extend an interface. Okay, by default all the methods within the interface are a public. You no need to define access modifiers for that interface. These are the basic rules for an interface which we need to consider. Like, you no need to define an access modifier public for them. Right. By default, those are public methods. You no need to define that. Then, what makes the difference between an abstract class and as well as an interface? An abstract class contains a set of abstract and as well as a non-abstract methods, whereas an interface contains only this abstract methods itself. An abstract class contains doesn't support a multiple in a multiple inheritance in Java, whereas the interface supports a multiple inheritance in Java. We'll show you a small example here. And we didn't study anything about a final keyword. That's fine. We will study final keyword moving ahead. Okay, cool. And the next thing is abstract is a keyword that is used to declare an abstract class. An interface is a keyword which is used to define an interface. Okay, that's fine. These are generic differences itself. Now, what I want to show you right now is let me expand my projects. Okay, and let me create a new interfaces. And I just want to show you how can we do these multiple inheritance concept in Java. So what I'm doing means let me create my interface one, inter one inter one. This is my first interface, and this is in this interface I'm doing public void login system. Okay, sorry, public void login. So we shouldn't write down any logic here. I'm just defining login here, void login, and now I'm creating another interface on top of it, where in which I want to make down a logout method inside of that. So here, interface of one and interface two are the two different interfaces whatever we have here. Now, what I'm doing means I'm creating a new Java class, example 35. And here, what I want to do is I know implements is a keyword which I can use using this. Okay, implements is a keyword that I can use in order to implement the interface methods. So public void login. I have implemented that system.out.println login. So what exactly the multiple inheritance means? At a time, a single class can implement multiple interfaces logics. So here, followed by this inter one, I'm defining inter2 here. Whenever you have a defined as an inter2, whatever the logics you need to implement as part of that interface 2, I'm just using this interface 2 here. Logout. See here, basically, interface 1 contains a login method and interface 2 contains a logout method. Both the login and a logout we have implemented, and the multiple inheritance means what we are doing means an interface followed by a comma we are specifying, and again we are doing this particular stuff here. Okay, and again we are just doing this particular stuff. So the ultimate point out over here is I can add a multiple interfaces here, and I can implement the logics present in those interface. This class I can treat it as a concrete class as it has a bunch of information, and all the stuff is a complete information itself. Now assume that I have created a new class with the main method, example 36 with the main methods. Okay, example 36 with the main method. Example 35 space obj is equal to new example 35. And using obj, I can access the login methods, and even using obj, I can access the logout method too. Both the methods I can access. The thing is, this login is from coming from an interface one, and this logout is coming from an interface two. Basically, login and a logout are coming from an interface of one and as well as an interface two. Obj dot. See, I'm just trying to call login and as well as a logout again. Obj dot obj dot logout again. I have just specified this login and a logout. That's it. Okay, I just specified this information. And whenever I run my test script, okay, automatically the login and a logout logic will be executed as part of these interfaces what we have created. Okay, as part of these interfaces what we have created. Okay, good enough, done the deal. So this is all about how exactly we are going to implement, okay, how exactly we are going to implement this multiple inheritance using an interface in Java. Okay, multiple inheritance using an interface inside this Java. That's fine. And the next concept of which I want to explain as part of the today's session is about exception handling mechanism in Java. And guys, today this exception handling mechanism is an introduction concept itself. We are not going to cover in detail about this exception handling mechanism. Just a high level overview on this exception handling mechanism we are covering in this Java today. Okay, so exception is an error event during the execution of a Java program or a test case which disturbs the test execution in between. Okay, and moreover, this is the most important feature available in Java programming language that allows us to handle runtime errors caused by this exception. Okay, so basically, what exactly this exception means? It's an unexpected event that interrupts the normal flow of the program. So the program will be executed in a flow, one step after another step. But an unwanted event that triggers in a middle which disturbs the execution, maybe which terminates the execution, which fails the execution, which we can treat it as an exception. Okay, so usually whenever the exception comes into the picture, directly the execution will be terminated. So what is the best example for this one? Assume that, okay, assume that, let me make a point here. Assume that I'm going for a long drive. Okay, so this is what my actual planned task is. Okay, this is what exactly my planned task is. An unexpected event comes into a picture. All of a sudden, there is a issue with my car engine, or all of a sudden, car tire. Okay, car tire got uh, all of a sudden the car tire got a, or completely I can say, car got completely a breakdown. So you travel for a couple of hours, all of a sudden there is an issue with your car engine and it stopped abruptly in the middle. So what it will happen, your planned activity is going for a drive, which got interrupted with an event or an exception, which is an issue with your car. Okay, which is an issue with your car. Maybe depending on that exception whatever it got encountered, it may take a couple of hours or couple of days time to resolve that particular issue, which will ultimately implement your journey, right? The same way here also, the unexpected events of which triggers causes a kind of a exception to your program basically. Okay, so basically in such situations we will get an error messages in your program. So, the simple and the most important thing as an automation tester, which we should do, is how we are handling the exceptions with a meaningful messages and a meaningful way. How we are dealing with those exceptions. We can consider this whole concept as an exception handling itself. Okay, basically, so whenever the exception comes into the picture, it will throw a system generated message. To understand that message more clearly, we need to handle those exceptions. Okay, that's fine. Immediately, a quick question will rise in our mind. I know in a car, maybe it might be an old car due to the usage and all those things. I may get a different issues in a car in my runtime, but why I may get exceptions in the real world? There are several reasons in getting down the exceptions. For suppose there might be a network connectivity issues and you are providing some data and that data is not there, or the file whatever you are trying to access, assume that you are trying to read the information from a file and the file is not there, you may get an exception. So these are the various possibilities where we are encountering a different kinds of exceptions in Java. Okay, exception handling is the most commonly used concept in your framework. Seriously, so whenever you are working on your projects, basically, you need to handle these exceptions. Immediately, a quick question will rise in our mind. What are all the various advantages if I'm handling these exceptions? Okay, so basically, that exceptions will make sure that the flow of the program doesn't break out whenever the exception comes into the picture. Okay, whenever the exception comes into the picture, we are not at all terminating that. Maybe we are just specifying it to proceed with a further logic. So by handling these exceptions, we need to make sure that all the statements should execute as per the flow, whatever we have designed, and the flow doesn't break in the middle because of these exceptions. So I can say in the car, whenever there is a breakdown, there should be a backup plan for me, basically an alternative car or a nearby transportation or some kind of an option which will be help for me in order to continue my journey without wasting my time because of that particular issue. Okay, good enough. That's fine. Okay, and then the next program out over here is, so I may see basically certain differences or certain keywords like an error or an exception. So what exactly this error and what exactly this exception is? Error indicates that something severe enough has gone wrong and the application should crash rather than handling that particular error. So an example for this one is maybe if the car tire is having an issue, immediately you can replace it. But for suppose if the engine got a completely hanged up, it's not possible for you to deal with that. So engine issue, the problem occurred in an engine, I can treat it as an error. The problem occurred in a tire or some brakes or some other functionality, we can treat it as an exception. Okay, and moreover, a driver who is driving the car can easily handle those exceptions. Like a tire, he can replace with another existing tire or another spare part. He can simply do that particular piece. The same way here also, exception means that occurred within a program. A developer or the tester who is creating the program can handle that exception, whereas the error cannot be handled. Okay. Good. So basically, in Java, there are multiple types of exceptions, whatever we have. Okay, the complete exception handling mechanism in Java can be dealt with the two different things. One is a checked exceptions, and we can consider it as a types of exceptions. One is a checked exceptions, and another one is an unchecked exceptions. Okay, so what exactly these checked exceptions are, and what exactly these unchecked exceptions are? Let us see basically those two. Okay, there are two types of exceptions in Java as shown below. One is an checked exceptions, and another thing is an unchecked exceptions. And how we are going to handle the exceptions, it's going to be a different thing. And even there is a flow basically how exactly the exception hierarchy will be there. We will see that particular flow moving ahead. But ultimately here I can show you this particular point, which is what is a checked exception and what is an unchecked exceptions. Checked exceptions are those exceptions which are checked during the compile time and need to be catched during the compilation itself. If the compiler will not find a catch block, then it will show a compilation exception. Very simple example for this one is using a thread.sleep in your program. If at all you are using a thread.sleep command in your program, if you not put it inside a try catch block, or if you are not surrounding with a throws exception, in such situations, immediately your Java program will throw an error. And a new question will comes in our mind, what exactly this a thread dot sleep means. So it's an explicitly a timeout, which we are calling out in Java. Moving ahead with the further examples in a WebDriver, we will study about it. So the point out over here is there are certain syntaxes for everything you need to remember, and if you are not following that syntaxes, immediately your Java program will throw that this is an exception, which we can call it as a checked exception. At the time of a scripting itself, even you can easily understand that. Whereas an unchecked exceptions are those exceptions which are not checked during the compile time. Generally, these exceptions are occurred during the runtime. For suppose a simple program I have created stating that get the data from an Excel file and use it in a program. I have created a program and I deleted my file from that folder. Okay, the file is no longer exist in a folder, but I have written a program. But my program don't know until it executed in the runtime whether the file is there or not. In the runtime, it will go to that location and it will check out whether that particular file is there or not. If the file is not there, then it will throw an exception. Right. That exception will occur in the runtime stating that the file not found in that location. Right. So the point here is at the time of writing down the code, your Java won't check into that folder checking that whether that file is there in that location or not. Whenever you are executing your program, your Java will go and check it out whether that particular file is there in that particular location or not. Okay, cool. So this concept we can treat it as a basically an type of exceptions. One is a checked exception and another one is an unchecked exceptions. And this screenshot will gives us a clear cut understanding about so what are all the categories will comes as part of an exceptions, and what are all the categories we fall under an error. So basically we have a seen error and an exception. Exception can be fixed and error cannot be fixed, right? Basically, so here all these things are come or fall under this particular object hierarchy itself. Anyways, we will see that runtime exception, IO exception, index out of bounds exception, file not bound exception, array out of bounds exception, all those things we will see as part of these exceptions itself, which we will see moving ahead. Not exactly right now, we will see that concept moving ahead. Okay, that's fine. And then the next point out over here is a try catch block. So what exactly this a try catch block is? Whenever you are creating a program, if your program is having an issues, the code whatever it has inside it, which may cause an error, will be placed inside a try block. I can say that the try block contains a set of statements or a code where an exception occur, where there is a possibility of coming an exception. How would you know? You should analyze that. So I assume that the file not found exception. I know if I have deleted the file, maybe the exception will comes into the picture. That's the reason you will surround that reading file logic inside a try block. Okay, fine. A try will always have a catch block followed it, which handles the exception that associated inside a try block. Okay, a try block must be followed by a catch block or a finally block or both the things. Okay, a try will have a catch, or will have a finally, or will have a both. Let me show you a simple example how this a try catch looks like. So here, example 37 with a main method. So here, what I'm doing right now is try, and here what I'm doing inside that, inside a try block, I'm just using a system.out.println error block. This line may cause an error. So I have a defined that. This line may cause an error. I have a defined that. Okay, a try block is there. And if you observe the catch block basically, so I need to create a catch. So here I'm stating catch. That's it. So whatever the error you are getting inside the try block, catch that particular exception. And if you can see the exception handling mechanism here, we have runtime exception, IO exception, index out of bounds exception, file not found exception, bunch of exceptions. But all these things falls under a throwable itself. So here I can say throwable of a E. So the meaning is whatever the exception comes into the picture within the try block, catch that exception and execute the logic inside it. System.out.println. Okay, system.out.println error encountered in try block. Hence, we are in a catch block. Okay, assume that I have a defined this particular confirmation message here. So there is a try block, and whenever the error encountered, then only the catch block logic will be executed. Okay, so if I'm executing this, assume that I didn't encounter any issues in a try block, then it won't execute the logic present in a catch block. When it will execute, if it is executing the code present in a try block, if it encountered any exceptions, then only the logic present in the catch block will be executed. In the current situation, there is a no issue in the try block. Whenever I'm just executing my test script, error block, this line may cause an error. That's it. Or I can say try block, this line may cause an error basically. Okay, try block, this block may contain an error. That's it. That's the clearly we have a call it out. As it doesn't have any issues, it's not jumping onto a catch block. Okay, fine. Now, when I try to execute my test scripts, it's just a syntax issue. Right. So it doesn't fall under these things. I can say, the examples for this try catch, we can go with a bunch of examples for this try catch. Okay, so the example what I can do for this try catch exception out over here is maybe you can use a division operation with the 0. Uh, 30 or 1 divided by 0, 2 divided by 0, all those things will comes inside a catch block itself. Okay, whenever there is an error, that comes inside a catch block itself. And basically here I have a surrounded with only one try block. Maybe I can surround it with a multiple catch blocks. Like I can define index out of bounds exception as a one catch block, and I can write down the logic here that index out of bounds. So whenever in the try block there is an index out of bounds exception, then only this catch will be executed. If it is having some other exception, it won't execute it. Instead of an index out of bounds exception, maybe we may get some arithmetic exceptions like issue with a number. So in such situations, we are going to deal with these arithmetic exceptions. So the thing is, you may have a multiple catches with respect to the unique exceptions, or in a simple terms, I can deal with a single catch block with a throwable will be a major exception, or I can say throwable is a superclass for all the exceptions. If you define it as a throwable, whatever the exception might come inside the try block, it might be an I can say It might be an index out of bounds exception. It might be an arithmetic exception. Whatever it might be, you can directly jump onto this one itself. Int a is equal to, assume that I'm defining this integer 1 comma 2, and here system.out.println a of a 5. I know a is having a two values. I am trying to get a as a 5. So whenever I executed my test script, it should throw an error message basically, but now it's getting an info stating that error encountered inside a try block. The reason is a of a 5 itself is not there. To know what exactly the exception it's being populated, I can say that e dot print stack trace. E dot a print stack trace is an info which will be printing down to the console stating that what exactly the exception you are encountering. See here, array index out of bounds the exception 5. So you are trying to get an index of a 5 which is not there inside that. That's the reason you are getting array out of a bounds exception. For suppose instead of array out of bounds exception, I can define system.out.println 10 divided by 0. Okay, usually divided by 0 will throw an infinite, and here it's showing as an arithmetic exception. So whenever you are using a print stack trace, it will be printing down the actual reason behind the failure. Okay, the actual reason behind the failure here to the console. So a catch block with a throwable, as a throwable is a superclass for all the exceptions, the throwable will catch any kind of an exception whatever we have, and it will be printing down that information here. Okay, good. And then the next one out on top of this one is a finally, a try, catch, and a finally. See here, I'm writing down another logic, finally. Okay, inside of this finally, I'm printing down a message that system.out.println, we are in a finally of a try catch block. Okay, we are in a finally of a try catch block. So whenever I'm executing my test script, it's printing down that information. We are in a finally of a try catch block. So the ultimate point out over here is the logic present in a finally will be executed. Or I can say a finally contains, it's a block basically. A finally block contains all the crucial statements that must be executed whether the exception is handling or not. Whether you are dealing with the exception or not, I don't mind basically, but I just want to handle, or I just want to execute the logic present inside this finally. For suppose I'm getting an index out of bounds exception for this, instead of defining this one, if I am defining, okay, see here, I know line number 13 will cause an, okay, I know line number 13 will cause an exception, and that exception is an arithmetic exception. But here we are using this index out of bounds exception in a catch block. As we are using an index out of bounds, definitely this catch won't be executed, but the logic present in a finally will be executed. So when I run my test script as a Java application saying that we are in a finally block, and this is the exception what it has, you haven't handled that particular exception, and the catch block is not executed. So the ultimate point out over here is whether the logic is there or not, the finally block will be executed. It's a mandatory code. The statement present in a finally block within a try catch will always be executed regardless whether you are handling that exception or not. Okay, but usually it's up to you how you want to define the finally block. That's up to you. Okay, and most important thing is this finally block will be associated with a try catch block itself. Okay, and you cannot use this finally without using a try catch block. Okay, and moreover, this finally is not a mandatory thing, it's an optional thing. And even if you observe the previous example, without this finally, we have handled the exception as well. It's up to you whether you want to handle this finally or not. Okay, and always the logic defined in a finally will be executed. Okay, the logic present in a final will always be executed. Usually, how you will be dealing with a finally means whenever you are working on a files, and inside this finally, you will be using down the logic to terminate that particular file instance and all those things we are going to define within this finally block. This is all about an exception handling mechanism. We do have a few more options also, like a throws, a keyword, and all those things, which we will study in the next session.